Have you ever stopped to think about the data behind a huge business decision, or maybe even a groundbreaking scientific study? There's this invisible threat, a hidden problem that could be quietly corrupting all that important research. We're talking about the lazy clicker. So let's just cut right to the chase. If you've ever worked with surveys, this is for you. Are these so-called lazy clickers, people who aren't really paying attention, quietly ruining your data?
Okay, so what are we really talking about here? Well, the official term for it is careless responding. And look, this isn't just someone mashing random buttons. It's when people answer without really paying attention. And what's super interesting is that it often creates these non-random, low-effort patterns. Like straight lining, where someone just clicks 33333 all the way down. Or even a seesaw pattern, where they go 1 2 3 2 1.
Now, you might be thinking, okay, but how big of a deal is this really? Well, the numbers are kind of shocking. Research shows that careless responding can mess up anywhere from a small percentage of a dataset to, get this, in some studies, more than half of all the participants. Especially now with so many surveys online, this has become a massive problem for anyone who relies on data. So what's the real damage here? Well, it's pretty bad. This junk data can make it look like two things are related when they're not, or it can completely hide a real connection that you're looking for. It messes with your scales, and it leads to what scientists call type 1 and type 2 errors, which, is a fancy way of saying you either find something that isn't real or you miss something that is. Bottom line, this leads to bad science, terrible business strategies, just flawed conclusions all around. So here's our game plan. We've seen the threat. Next, we're going to look at why the old tools for catching this stuff just don't cut it. Then we'll introduce a brand new approach, show you the proof that it works, and finally give you a new toolkit that you can use to clean up your own data. All right, so you might be thinking, surely people have tried to fix this before, right? And you're right, they have. But it turns out the traditional methods have some pretty big blind spots. This slide just shows the problem perfectly. There's a common tool called the Longstring Index, and it's great at catching someone who just answers 11111. That's easy, right? But what about a slightly more creative, lazy clicker? Someone who makes a little seesaw pattern, like 1 2 3 4 5 and then back down. I mean, that's clearly not a thoughtful response, but the Longstring Index completely misses it. It's a careless pattern that just slips right through the net. So this is where things get really interesting. A new method with the perfect name LASR takes a totally different approach. It's built on this really clever idea from statistics called Markov chains, and it's designed specifically to catch those predictable patterns that the other tools miss. The whole idea behind LASR is just beautifully simple. The researchers figured that for someone who's just mindlessly clicking, their last answer is a really good predictor of what their next answer will be. Think about it. A careful person's answer depends on the question. A careless person's answer? It just depends on what they clicked a second ago. So how does it actually work? Well, it's a neat little three-step process. First, it just counts all the transitions, like how many times did a 4 get followed by a 5. Next, it turns those raw counts into probabilities. And finally, it crunches all of that into a single LASR score. That score is just a measure of how predictable the person's answers were. A higher score means a more predictable pattern, which means it's way more likely they were just clicking carelessly. All right, that all sounds great in theory, but the million-dollar question is, does it actually work in the real world? Well, the researchers put LASR to the test on some big public data sets to see if it could really separate the good data from the bad. Let's take a look at the proof. Okay, this is just wow. The researchers used a really well-known career interest survey where some themes are known opposites. For example, realistic and social interests. They shouldn't be related at all. Now look at the group that LASR flagged as careful. The correlations are right around 0, exactly what the theory predicts. But the careless group? The correlations are huge and positive. This data is just nonsense. It's not just random noise, it's actively misleading you. LASR totally nailed it. And this chart really drives the point home. The researchers compared their results to the established scientific consensus. And what they found was that the data from the careful group was much, much closer to the truth. The deviation was tiny. But the careless group, they were way off. So by using LASR to clean the data, the results got a whole lot more accurate. Okay, so we've seen the proof. This tool works. So now, let's get practical. How can you actually use this to get better, more reliable results from your own work? This brings up a really crucial question, though. If LASR gives every single person a score, where do you draw the line? I mean, how high does a score need to be before you flag them as careless? Just picking an arbitrary number, like the top 5%, feels a little bit like guesswork, right? And this is where the researchers came up with another really elegant solution. They suggest using something called the Kedel algorithm. Basically, if you sort all the scores from highest to lowest and plot them on a graph, you see this sharp drop, and then it flattens out. That elbow in the curve, or the knee, is the natural dividing point, and the Kedel algorithm automatically finds that exact spot for you in your specific data. It takes all the guesswork out of it.
So, what's the playbook here? Well, the researchers give us some clear best practices. Use Lazar for what it's amazing at, finding those patterned responses. But remember, no single tool is a magic bullet. For purely random clicking, other tools actually work better. So the best strategy is to combine tools for the most robust cleaning. Oh, and for Lazar to really work its magic, you'll want to use it on surveys that have at least 20 items.
Now, this is the part that I think makes this research so powerful. You don't have to be a stats wizard or a programmer to use this thing. The researchers made it totally free and available through a super simple web app. You literally just upload your data, click a few buttons, and it calculates everything for you. The Lazar scores, other indexes, even that K-needle cutoff point. It basically democratizes high-quality data cleaning for everyone. And that brings us to the final thought here. Just imagine the real insights, the true effects, the groundbreaking discoveries that might be hiding in our data right now, just buried under all this noise from careless clicks. When we clean our data better, we get closer to the truth. So the question I want to leave you with is this: what secrets will better data unlock for you?